giant jellyfish swimming through space, trailing stars and plasma across the cosmos. Welcome to Celestial Wonders. Today we're diving into the cosmic jellyfish, what's swimming through our galaxy. These bizarre galaxies reshape our universe, and their secrets will blow your mind. Buckle up, this is the wildest cosmic ride yet. Imagine a galaxy that looks like a jellyfish, its tentacles trailing millions of light years. These are jellyfish galaxies found in galaxy clusters where ram pressure stripping, a cosmic wind, strips gas from their disks, forming glowing tails of star-forming gas, per a 2017 Nature study. A 2018 NASA report describes their tendrils as cosmic tentacles, bursting with new stars. Obscure fact. A 2019 astrophysical journal study notes jellyfish galaxies like ESO 137-001 have tails stretching 260,000 light-years, twice the Milky Way's width. Unlike typical spirals, their gas loss triggers starbursts, per a 2020 Monthly Notices report. Found in clusters like Hubble 2744, their cosmic oddities reshaping our view of galaxy evolution. Galaxies were first classified by Hubble in the 1920s per a 2017 Sky and Telescope article, but jellyfish galaxies baffled astronomers until the 1980s when ram pressure stripping was modeled, per a 2018 Journal of Astrophysics. Their discovery echoes Herschel's 1780s galaxy catalogues, expanding our cosmic map. These galaxies lose their lifeblood, gas. But they still manage to birth new stars in defiance. Their struggle and beauty really tug at us, like a cosmic dance of loss and creation. In 2017, astronomers spotted a bizarre USS jellyfish in galaxy cluster Able 2877, about 340 million light-years away. A 2021 Astrophysical Journal study describes this million light-year wide plasma structure, lit up at low radio frequencies, 87.5 to 215.5 MHz, vanishing above 200 MHz, dubbed a polyphenix. It's actually a relic of ancient black holes reignited by shock waves. Here's an obscure fact. A 2021 Science Daily report explains that the USS Jellyfish's ultra-steep spectrum, which makes it bright at FM radio but invisible higher up, is totally unique. This suggests plasma mixing and gentle shocks, according to lead researcher Torrance Hodgson. Unlike typical radio galaxies, it's a ghostly fossil, briefly revived as described in a 2018 Nature Communications study. Radio astronomy, really began with Jansky's discoveries back in the 1930s, as highlighted in a 2017 Nature Reviews Physics article. The MWA, which is actually a precursor to the Square Kilometre Array, kind of echoes Grotto Reber's backyard dishes from the 1940s, unlocking these low-frequency wonders like the USS Jellyfish, according to a 2019 astronomy report. This ancient relic, reborn for just a moment, kind of whispers of lost galaxies. Its fleeting glow really pulls us into the deep past of the cosmos. A story full of revival and mystery. Jellyfish galaxies actually form when galaxies dive into clusters facing ram pressure from the ICM, which is this hot, dense gas acting like a wind as described in a 2017 Nature study. And a 2019 Astrophysical Journal points out that this process strips away gas, triggering starbursts in the tails, just like what we see in JWST using ESO's MUSE. Some of those tails even host clumps with 10 million stars, almost like mini galaxies themselves. Here's an obscure fact you might not have heard. Back in 2020, a Nature study found that 6 out of 7 jellyfish galaxies actually host active black holes. These black holes are fueled by stripped gas, which really boosts their activity. And according to a 2023 Monthly Notices report, the tails of these galaxies are magnetized, with fields aligning along the tentacles, based on meerkat data. This suggests thermal instability is at work, not dissolution. Zwicky's cluster studies from the 1930s, as mentioned in a 2018 Physics Today article, hinted at the effects of the intracluster medium. Modern multi-wavelength observations, like Hubble's 2018 D100 study, build on Chandra's 1999 X-ray legacy as described in a 2017 Space Science Reviews, revealing the fascinating dynamics of jellyfish galaxies. Jellyfish galaxies really fight to shine, birthing new stars even amid chaos. Their resilience kind of mirrors our own, a cosmic saga of transformation and survival. Jellyfish galaxies are swimming clusters like Virgo, Coma, and Perseus, according to a 2021 Astronomy and Astrophysics study. A 2023 Monthly Notices survey found that Perseus in particular hosts jellyfish galaxies with radio tails, which have been traced by LOFAR at 144 MHz. Showing that cosmic ray electrons are stripped right alongside the gas. They're rare though, less than 1% of cluster galaxies according to a 2019 Astrophysical Journal estimate. Here's an obscure fact. A 2024 Astrobyte study using TNG-50 simulations found that jellyfish galaxies lose 98% of their cold gas in their first cluster orbit. This gas loss actually fuels star formation in the host galaxy, as reported in a 2023 Monthly Notices paper. And interestingly, their tails, seen in X-ray, ultraviolet and radio, can persist for billions of years, according to a 2017 Astrophysical Journal study. Slipher's redshift studies from way back in the 1910s, according to a 2017 Journal of Astronomical History article, really laid the groundwork for understanding cluster dynamics. The GASP project, which started in 2017, kind of echoes Messier's 18th century cluster cataloging, but now uses MUSE to map out jellyfish tails as described in a 2019 Nature Astronomy article. These galaxies caught mid-transformation remind us that change can, actually spark beauty. Their journey through clusters inspires us to embrace our own cosmic shifts. The hunt for jellyfish galaxies is, really accelerating. JWST since 2022 studies ESO 137-001 star-forming tails, according to a 2019 NASA report. A 2021 astrophysical journal predicts the square-kilometer array, launching in the 2020s, could find more USS jellyfish-like structures, revealing ancient plasma relics. Here's an obscure fact. A 2023 monthly notices study identified 5,307 jellyfish in TNG 50 via Zooniverse's Cosmological Jellyfish Project, showing they form at high redshifts according to a 2023 academic OUP report. Future missions like Athena in the 2030s could map X-ray tails per a 2020 Nature Astronomy forecast. Modern surveys actually echo Herschel's star catalogs from the 1800s according to a 2017 astronomy article. The JWST project's 2017 to 2024 MUSE data, as reported in a 2024 Cordis report, really builds on Hale's cluster photography from the 1920s, unlocking, the story of Jellyfish Galaxy evolution. Jellyfish galaxies in a way unite us all in cosmic discovery, with their tails kind of lighting our path forward. They urge us to keep exploring, to keep chasing the universe's wildest wonders. Cosmic jellyfish, galaxies and plasma relics rewrite our universe's story. A 2020 Nature Astronomy study calls them keys to galaxy evolution, their tails tracing star birth and black hole feasts. From Able 2877 to Coma, they spark awe, binding us to the cosmos's past and future. These celestial swimmers remind us the universe is alive with mystery. Let's keep chasing their trails, dreaming under the stars. Which jellyfish stunned you, JW100's starry tail or the USS Jellyfish's ghostly glow? Drop it in the comments. If this cosmic saga gripped you, smash that like button, subscribe to Celestial Wonders and hit the bell for more. Next, we're exploring the exoplanet that rains iron. You won't believe the science. Thanks for swimming through the cosmos with us. Until next time, keep chasing celestial wonders.